Okay, so today what we're going to do is the definition of the integral, or how to calculate the area under a curve using the definition of the integral. So as you know, an integral is basically the area between a curve and the x-axis. So in this case, it'll be the area beneath this curve and the x-axis, and it has to be defined on an interval to be a definite integral. So let's say a to b, and we want to find this area under the curve. So the way we're going to do this is separate this area in a bunch of rectangles of same width, because we know that we can calculate the area of rectangles using the formula base times height. And the more rectangles you'll have, the more accurate your area approximation will be. The width of these triangles is going to be called, these rectangles is going to be called delta x, and it's going to be the same for all rectangles. The formula to find delta x is just b minus a divided by n, and n being the number of rectangles, which is 6 in this case. So if we write the Riemann sum for this thing, is going to be x1 times delta x, which is the height of the first rectangle times its width, plus the height of the second rectangle times its width, blah blah blah, till we reach the last one, which is f of xn, the height of the nth rectangle, which is the sixth one, times its width. So if we rewrite the write the actual Riemann sum, we have to use sigma notation, which is the big E, which just means the sum of all the points, and xi is just a sample point in the function, times the width, delta x. So let's choose a function f of x equals x squared, and let's put this on the interval from 0 to 1. So we want to calculate this area under the curve x squared on the interval 0 to 1. And delta x, b minus a over n, is going to be 1 minus 0 over n. So delta x will be 1 over n. So this is the width of each rectangle. So as you can see, the more rectangles we'll have, the smaller the width will be until it reaches 0, if we have infinity number of rectangles. So the first x1 will be calculated by putting a plus delta x, so 1 over a because a is 0. And the second one will just be a plus 2 times delta x, so 2 over n. 3 will be 3 over n, and for n it'll be n over n, because n times delta x is just n over n. So this is all the x points, right endpoints of all the rectangles. And somewhere in there we'll have xi equals a plus I times delta x. So rewriting this Riemann sum, it'll be f of x1 times delta x plus f of x2 times delta x, and blah blah blah, till we reach f of xn times delta x. This is just the areas of each triangle, if each rectangles added together. And somewhere in there we'll have f of xi delta x. So let's calculate each of the heights for the rectangles. So all you have to do to calculate the height is plug in the x value that we just found into the function. So just square it. So first one is 1 over n squared, second one 2 over n squared, blah blah blah. F of xi will be I squared over n squared, and the f of xn will be n over n squared. we'll just rewrite these. 1 over n to n squared times 1 over n, which is delta x, plus 2 over 2 over n all squared, I over n all squared, times all times the delta x. So each term is multiplied by the delta x, which is 1 over n. But the only one we're gonna keep in mind is the I squared over n squared times 1 over n. So if we factor out all the denominators, they all have n cubed as the denominator. We'll just be left with 1 squared plus 2 squared plus I squared, somewhere in there. And at the end we'll have n squared. So if we don't want to write all these numbers, instead of writing 3 little dots, we'll just use the sigma notation instead, like the big E, from I equals 1 to n. And since our I term is squared, we'll use this formula, which is the formula for the square of all the first n integers. So if we rewrite this with the constant 1 over n cubed times this formula that you don't have to learn it, you can just have it in your notes. And there's a formula for I, there's a formula for I squared, which is this one, and there's also a formula for I cubed. You can just search up the sigma notation for the sum of n integers and you'll find it. So if we apply the limit of to the Riemann sum as n approaches infinity, we'll write limit as n approaches infinity of all this So here we can cancel out one of the n's on the top and on the bottom. So we'll be left with limit as n approaches infinity of 1 over n squared times n plus 1 times n plus 2n plus 1 all over 6. And so if we factor out the 1 over 6 outside the limit, we'll be left with n plus 1 times 2n plus 1 times n. And so this limit, if we separate it into two fractions, it'll be n plus 1 over n and 2n plus 1 over n. If we just separate the n squared term on the bottom, and if we apply the limit, n over n is just 1, so and 1 over n is 1 over infinity, it'll be 0. 2 over n will just be 2, and 1 over n is just going to be 0. So 1 over 6 times 1 plus 0 is just 1, times 2 plus 0 is just 2, so 1 over 6 times 2, 2 over 6, and if we simplify this, it's 1 over 3, and this is units cubed.